In this chapter, we're going to be talking about functions, and today we're going to talk about an introduction to them, what that looks like as an equation, a graph, and a table. So we're going to have our heading look like this, so please make sure you get your heading on. You can always pause it if you need to. The first thing we're going to do is we are going to write a definition of the word function. So go ahead and write that down. And our definition, can you write any rule that assigns, we'll see what these look like in a minute, that assigns exactly one output value, By output value, I mean our y value. So can you put y value in parentheses? We're talking about a y value of a graph, table, or equation. So any rule that assigns exactly one output value for each input value. And by input value, I mean x value. So that means that an x cannot have two different y's. X has to go to a different y. So there are two ways we're going to look at today as a graph and a table to see if their relationships are functions. So can you write, it is a function if. First, we'll examine a graph. A graph is a function if. Can you put a little star here? Can you write the graph passes the vertical line test. So I'm going to show you some examples of what that means, and you might have heard of this term, vertical line test. So I'm going to leave about 4 spaces right here to write some words, but I want to skip down and show you what a graph would look like as a function and not a function. So I'm going to shift this down a little bit. Here's an example of a graph that is a function. So can you draw your x and y axis? And can you draw this U shape, this parabola shape for me? This U shape is a function because every time we draw a vertical line, this is your vertical line test, it never touches the vertical line more than once. It only touches it once, so it passes the vertical line test. So that is a function. So can you put function underneath that? That's your vertical line test. Here's an example of one that is not a function. I'm going to draw my x and y axis again. And this time I'm going to make this oval shape. This is not a function because if I draw a vertical line, it touches the relationship, that oval, twice. So it does not pass the vertical line test. So that is not a function. Can you write not a function? So that's how you can tell if a graph is a function or not. Now we're going to talk about a table. So before we talk about a table, I want to show you a quick video before we finish the notes, which represents, it's a vending machine. So if you can imagine, a vending machine is quite like a function. Let me share this with audio. If we have a vending machine and we want to go to a vending machine and press a button to get a specific snap, you can see on the screen before it starts, if you press the CO, it will give you a Nutter Butter. If it presses the C and the 2, it'll give you a goldfish, and so on. So we've got a minute video to watch.
A function is a lot like a vending machine. If we input into the vending machine, it would give. If we input C2, it would give us goldfish. And if we input E4 or E6, those options would give us gummies. Now, it's not a function. We could put in C0, but we may get tuna salad, or it would change every time. We're not sure, and that's not if we input the value of C0 to get Nutter Butters, now it is okay that we put in different values, but we know possibly get the same thing, and that's why we're inputting. It's okay if we input the same, but not okay if we get different outputs. Similar in that if we input 1x, we should get exactly 1. We can have an x, two different x's, same y, but not the other way around.
So back to the notes. What the video was sharing was that, let me stop, sorry. So what the video, the vending machine was showing was that you can press a button and you need to know specifically what you get. You can press 2 different buttons and get the same thing. So you can have 2 X's that give you the same Y, but you can't have 2 Y's that give you the same X. For instance, you can't press a button and get 2 different options. So that's very similar to a table. So now let's talk about the table. So if a table is a function, can you write, the table has each input paired with a single output. What that means is you can't have an X with 2 different Y's. So in parentheses, can we write, not a function if? This is important, not a function if. An X has 2 different Y's. And I'll show you some examples on the table. Not a function if an X has 2 different Y's. If you look at these graphs, every X is paired with a different Y in this first one. But if you look at this, you have this X value could be a 1, negative 1, paired with a negative number and a positive number. That is why it is not a function. Let me show you with a table what that would look like. So I'm going to go to the next page because I've run out of room. And I'm going to put my 2 tables down. So the first table, can you make it about 5 rows down and 2 columns across? So it looks something like this. So there's my 5 rows, and I have my 2 columns. I'm going to put X and Y in the top. And my X values, I'm going to put -5, -3, 3, and 5. For my Y values, I'm going to put next to that 23, 7, 7, and 23. This table represents a function because every X is different. You don't have an X going to 2 different Y's. You might have 2 Y's with 2 of the same Y's with an X, but that is okay. You just can't have an X going to 2 different Y's. So I'm going to put a little note here. All different X's. That is one of the reasons why it is a function. So if all the X's are different, it's automatically a function. Let me show you an example that is not a function. We're going to draw the same size table. So 5 across and 2 going down. And again, if I'm going too quick, you can pause. My headings are going to be X and Y as well. My X values are 23, 7, 7, and 23. My Y values that go with them are -5, -3, 3, and 5. Remember, it cannot be a function if you have an X going to 2 different Y's. If you notice, you have this 7 going with a -3, and you have the 7 going with a 3 as well. Here, you have a 23 going to a -5, and also a 23 going to a +5. So I'm going to put on the side, same X's with 2 different Y's. Same X's with 2 different Y's. Because of that, that is why it is not a function. So again, if you have all different x's, it would be a function because the x would not be going to two different y's. If you have the same x going to two different y's, that means it's not a function. Before you send a picture of these notes into Canvas for your assignment, please click on the link that's underneath the posted video. There is a quick survey that you are to fill out before you send your picture of the notes.